Hi students, we're going to be looking at the least common denominator and the greatest common multiple. And to do that, historically, well maybe I should say traditionally, mathematicians teach that by teaching prime factorization. I do a little bit of a shortcut, but I'm going to show you the prime factorization because it is important that you can take a number and take it down to the product of its primes. So let me give you an example. Let's say that we had the number 175. We'll make it easy. We'll start with 175. To do prime factorization, you simply stem this out and find two numbers, any two numbers that will divide into $1.75. I tend to, if it ends in if I can divide it into quarters, like money, I do. So I know this is 25 times 7 because 7 quarters gives me that value. Now once you stem them, if it's composite, you stem it again. If it's prime, you circle it because you're done. Okay, 25 is 5 times 5. And as you know, 5 times 5 is 5 squared. And they are prime. So when you list your prime factorization, you should list it numerically, smallest number first, 5 squared times 7. And it is 7 to the first, but remember, exponents are just understood. If there's not an exponent there, you understand that it's a 1. Okay, let's say that you have another number that's 250. All right, we're going to do the same thing. The easiest thing is to do 25 times 10. Both these are composite, so they both get a stem. And this is going to be 5 times 5. They're prime. And this is 2 times 5. Okay, listing this out, I have 2 to the first times 5 to the third. Now, if I was asked to find the greatest common factor, that means what's the biggest number that will divide into both of these? Well, I know it's that 7 won't go into this one, so I can't do that. However, 5 squared is 25, and there's a 5 squared hidden in there. So my greatest common factor here is 25. Also, if I was asked to find the least common multiple, it's a little harder to me. I need to list all these factors multiplied together without double dipping, without using something twice. So it's going to be 2 times 7. I know that I kind of skipped the 5, and that's because I have 5 squared here and 5 to the third. I'm going to use a 5 squared because I can't use a third because it doesn't go into both. Oh, it's the other way around. It's 5 to the third. I can't use a 5. It's 5 to the third. I can't use a 5 squared. See, I think that's kind of hard. So that's 2 times 7 is 14 times 125. And 125 times 14 is 1,750. Now, I'm not real confident that this is my GCF and this is my LCM of these two numbers, because I don't do this a lot. I mean, I think it's important that you can do it, but let me show you what I do. I will put them both in what I call an upside down divide sign. So I'm going to do 175. Let me use something a little thicker. 175 and 250. Upside down divide. And I can find any number that will go into both. Well, 25 goes into both. So now 175 divided by 25 gives me 7. And 250 divided by 25 gives me 10, right? And now look, 7 times 10. Is there any number that will go into 7 that will go into 10? No, there's not. So I'm done. So this is what I do. This is my greatest common factor. Everything that's on the left-hand side becomes your greatest common factor. And I'll show you what to do if there's more than one in just a second. Everything on this L See this L? Gets multiplied together. So it's 70. 7 times 10 is 70. And 70 times 25 gives me that 1750. So that's my LCM. So those numbers were right over here. Where'd they go? They went up. They were correct. But man, I thought they were hard to get to. Let's try 2 more numbers. Let's say 630 and 720. Okay? All right, I'm going to look at both of these and realize, oh, look, they both divide by 10. Okay, so that means 63 and 72 because I did 630 divided by 10 to get 63, 720 divided by 10 to get 72. Looking at both these, let's pretend that I go, okay, I know 3 will go into them. And I know you're probably screaming at me saying, there's something bigger than 3, but let's just do 3. So 63 divided by 3 is 21. 72 divided by 3, I think, is 24. But I'm going to check. It's 24. And then you go, oh, look, 3 will go into these 2. Because you can use your divisibility rules all the way down. 21 divided by 3 is 7. 24 divided by 3 is 8. Okay, I'm done. Because if you have 2 numbers right next to each other, they don't divide by anything the same. So now let's do my greatest common factor. It's everything on the left multiplied together. So it's 10 times 3 times 3, which is 90. Don't know why I picked that big old fat lavender, but I did. And then to find, that's my GCF. My LCM is everything on this L, right? So it's actually 90 times 56, because 7 times 8 is 56. And so that's 5,040. So the LCM is 5,040, and the GCF is 90. I hope you see this upside down divide. No, it doesn't factor out the primes, but it is, a good way to get to that answer pretty quickly. What happens if you have 3 numbers, though? That gets a little hairy. Let me show you. Okay, now in this one, you'll be tempted to put all 3 inside the upside down divide. I found that doesn't work. So you pick any 2. I'm going to pick the biggest 2. Although it really doesn't matter. I've done it both ways and it doesn't matter. So I'm going to divide both by 5. 60 divided by 5 is 12. 35 divided by 5 is 7. Now I can't go any further. And 5 times 12 is 60 times 7, that's 420. So my LCM of that is 420. I'm just going to put the 420 in with the smallest one. Usually I check and see if the small one will go into it. Sometimes it does. But let's say that I don't know to do that. And I'm going to divide by 5. Well, 420 divided by 10 will be 42. So dividing it by 5 is going to be 84, isn't it? Let me check. Yes. And 15 divided by 5 is 3. But both these, using your divisibility rule, can you tell that 84 is divisible by 3? So I'm going to divide both by 3. 84 divided by 3 is actually 28. And 3 divided by 3 is 1. So now if I multiply everything on this, I get 28 times 15. I think you know what it is. And it is 420. So 420 is the LCM, which if you're adding fractions with these 3 denominators, that's what you have to change to. So that's how you do the least common multiple. To me, the greatest common factor, if I had to do that, I would just pick out 2 of them. It's 5. See if it'll go into the third one. If there's anything bigger, so usually you can just kind of eyeball that because there's 3 of them. So that's pretty, it excludes a whole bunch of numbers. So that one's not too bad. But that's the upside down divide to help you with finding the LCM and the GCF.